Hello and welcome. So let's start with today's session. So let me just go through it. So we are in this chapter, introduction to vector, and we have covered linear combination of vectors. Also, we have covered the problems on this chapter. Now we have so we are in this length and dot product, and we have covered the theory part, you can say. And now in this today's session we will be looking at the problems based on this topic, right? Problems, and you will have the assignment also, you will have the homework also. So then you will this today's lecture will be the end of this subtopic. After that we will be starting with this matrices. And regarding the language preferences, so मैंने decide किया है that we will go for both English and Hindi. So also I think जो भी साउथ साइड से है, जो भी साउथ स्टूडेंट्स है, आई थिंक you will not have much problem because most of the time I will be speaking in English. So because yeah, so that is all. So let's look at the reviews of previous topic, and we will start with the questions. Thank you. If you have anything, any points, let me know in the comment section or any of my post, or you can mail me also. So yeah, let's start with today's session. Okay, let's review what we have done in last video. So we looked at the dot product, right? So ये first point क्या बोल रहा है ना कि how you can take the dot product, right? And dot product जो है वो dot product is nothing but the multiplication of two vector. फर्स्ट वीडियो में हम लोगों ने क्या देखा था? मल्टीप्लीकेशन विथ अ स्केलर, राइट? स्केलर इज अ नंबर. नाउ इन दिस वीडियो वी लुक्ड एट द डॉट प्रोडक्ट, एंड दिस डॉट प्रोडक्ट इज नथिंग बट द मल्टीप्लीकेशन ऑफ टू वेक्टर्स, राइट? और परफॉर्म कैसे करना है तो दैट वी हैव सीन, एंड दिस इज व्हाट वी आई हैव रिटन इन द फर्स्ट पॉइंट. सो यू डू नॉट हैव टू डू नथिंग. अगर आपके पास दो वेक्टर है v1, लेट्स अप ये इस वेक्टर का v बोल दो, एंड इफ़ यू आर कैलकुलेटिंग द डॉट प्रोडक्ट विद दिस अनदर वेक्टर दैट इज w, लेट्स कॉल दिस वेक्टर w. सो कैसे आपको करना है डॉट प्रोडक्ट कैसे लेना है? सिंपली आप कॉम्पोनेंट वाइज मल्टीप्लाई कर दो, कॉम्पोनेंट वाइज मल्टीप्लाई कर दो और सबका ऐड निकाल दो. सो दैट इज़ हाउ वी कैलकुलेट द डॉट प्रोडक्ट बिटवीन टू वेक्टर्स, राइट? और सेम आइडिया को एक्सटेंड कर सकते हैं हम लोग n डायमेंशन तक, ये भी हम लोगों ने देखा था. नाउ द सेकेंड पॉइंट इज दैट अगर कोई वेक्टर है देन हाउ यू विल फाइंड द लेंथ ऑफ दैट वेक्टर, राइट? सो टू फाइंड द लेंथ ऑफ दैट ए वेक्टर, व्हाट वी डू इज वी टेक द डॉट प्रोडक्ट विथ इट सेल्फ. हम लोग क्या करते हैं ना कि जो वेक्टर दिया हुआ है उसका डॉट प्रोडक्ट उसी के साथ ले लेंगे. सो लेट्स सपोज दिस वेक्टर वी है, ठीक? तो अगर आपको इसका लेंथ निकालना है देन व्हाट यू विल डू, यू विल टेक द डॉट प्रोडक्ट विथ इट सेल्फ, right? And that will give you the length. We have seen this, so I'm not going to explain this, and this idea can be again extended to the n dimensional space. और फिर नेक्स्ट हम लोगों ने क्या देखा था कि अगर कोई वेक्टर v है, लेट्स सपोज दिस वेक्टर v, और आपको इस डायरेक्शन में जिस डायरेक्शन में v है, इन दैट डायरेक्शन इफ यू हैव टू फाइंड द यूनिट वेक्टर, हाउ यू आर गोइंग टू फाइंड? लेट्स सपोज दैट इस डायरेक्शन में एक यूनिट वेक्टर u है, देन हाउ यू विल गोइंग टू फाइंड द vector u that is in the direction of v, and this u is a unit vector. Let me reframe it, let me say it one more time. So let's suppose you have this vector v, and I am asking to find a vector u that is a unit vector in the direction of this vector v, right? अगर आपके पास कोई वेक्टर v है, अगर मैं ये पूछूं कि आप मुझे एक यूनिट वेक्टर दो इन द डायरेक्शन ऑफ v, and that unit vector is u, then what you will do, you will say that this is a unit vector in the direction of v, right? And since this is a unit vector, so I am going to divide it by the length of v, right? So this is what we have discussed so far regarding the length of a vector and a unit vector in the direction of some vector. Also एक पॉइंट मैं यहाँ पे मेंशन करना चाहूँगा, ये डॉट प्रोडक्ट को हम लोग और क्या बोलते हैं, that we call another name, that is the inner product. So we do the inner product. अब अगर फिर आपके दिमाग में ये भी आ रहा होगा कि अगर इनर है तो आउटर प्रोडक्ट भी होगा. Yes, obviously we have the outer product. We will talk about this in further videos. Okay, now coming to the third point, the dot product. If you take the dot product and if it is 0, then vector, then angle between those two vector is going to be 90 degree. It is obvious, and it is known to you as you like from earlier classes, and this is the cosine formula, right? That will give you the angle between the two vector, right? So and also this length of a vector, you can say ये चीज़ जो है आपका, this is length of a vector, right? And you can say it this as norm norm of a vector. And this is Schwarz inequality, that tells that अगर आप absolute value लोगे dot product का, तो that would be less than equals to the individual length of that vector, the product of the individual length of that product, right? So not important, but still to have, good to have. Okay, और एक पॉइंट ये है कि आप w डॉट v निकालो या v डॉट w निकालो, बोथ आर गोइंग टू बी द सेम. ऑर्डर डॉट प्रोडक्ट आप किसी भी ऑर्डर में लो, दैट इज नॉट गोइंग टू चेंज द एंड रिजल्ट, राइट? So that was the summary regarding the last lecture what we have seen so far. Now we will jump to the problems. Okay, let's look the first problem. We have three goods to buy and sell, and their prices are P1, P2, P3 for each unit. The quantities we buy or sell are Q1, Q2, Q3, and these will be positive when we sell, and these quantity will be negative when we buy. So we have been asked that total income, what will be the total income? Easy problem है. How you can do that? You can simply say that total income would be, so total income जो है सिंपल, आप क्या करो, P1 इंटू P1 प्राइस है हर एक यूनिट का, हमने कितना खरीदा इसका, तो Q1 यूनिट खरीदा. P2 प्राइस है सेकेंड यूनिट का, सेकेंड प्रोडक्ट का, और एक यूनिट का प्राइस P2 है, हमने कितना खरीदा, तो Q2 खरीदा, तो वो प्रोडक्ट कर दो. थर्ड यूनिट का प्राइस, थर्ड गुड का जो है पर यूनिट प्राइस P3 है, एंड हमने कितना खरीदा, Q3 खरीदा, तो उसको प्रोडक्ट कर दो और सबको ऐड कर दो. सो दैट विल गिव यू द टोटल इनकम, राइट? सो now the main point is here to look this problem as a, you can say, you can look this price as a price vector, right? So this list represents the price vector. So the goal of this question is to make realize that you can consider a list as a vector, right? So we can say this as a price vector, right? And how you will write this price vector, it will have the component, three component, P1, P2, P3, right? Or can you tell me that what will be the, so इस वेक्टर का डायमेंशन क्या होगा? तीन components है ना, 1, 2, 3. So this vector belongs to some three-dimensional space, right? Or you can think this quantity as a quantity vector, right? So we have the another vector that we can call it the quantity quantity vector, right? Or it has also the 3 components. And if you look at this total income, so what we are doing is that we are taking the dot product of this price vector and the quantity vector, and this is giving you the total income. So if we have to look this problem in terms of vector, so we can say that the total income, let's call this P and this call this Q. So the total income would be P dot Q, right? And you can simply do the vector multiplication, right? And that will give you this. So how you can do the vector multiplication? This, and at the end you are going to add all those, right? Okay, now the point is that so we have the 3 goods, right? हम लोग के पास 3 goods है. Then we listed the price per unit as P1, P2, P3. Assume करो आप कि आपके पास thousands of goods है. If you have the thousands of goods, then what will be the dimension of this price vector? And what will be the dimension of this quantity vector? It would be 1000, right? So here right now we have this R cube, and this one is also R cube, right? So okay, now let's look at this problem number 2. So today we will have some easy questions. So we have that find a unit vector u in the direction of v. So कैसे हम लोग फाइंड करेंगे? इफ वी हैव टू फाइंड द, तो यहाँ पे 2 चीज़ इंपॉर्टेंट है, राइट? इन द डायरेक्शन ऑफ v एंड दिस u इज अ यूनिट वेक्टर. So this u is in the direction of v and a unit vector. So if it is in the direction of v, then this u will be in the direction of v, and this u is also a unit vector. That means what we are going to do, we are going to make this unit vector. And how we can do that? We can simply divide the length of this vector v. So ये अब जो vector u होगा, that will be unit vector or in the direction of vector v, right? So this is multiplication here. Okay, so we have given this vector v, right? So v जो है आपका 3 है, 4 है, right? And if we have to find the norm of v, or you can say length of v, बात एक ही है. तो आप क्या करोगे? सिंपल कैसे निकालते हैं लेंथ? आप डॉट प्रोडक्ट ले लोगे विथ इट सेल्फ, राइट? एंड इफ यू टेक द डॉट प्रोडक्ट, that 3 times 3 will get multiplied with 9, and 4 times 4, and at the end you are going to add those. So that will give you the length squared, right? So that will give you the length squared. So this is not the length exactly, but the length square, and you will get 25 or 5. So 25, right? But this norm of v, that will be equal to the root over of this v dot v. So that will be 5, right? So what will be this vector u? So vector u होगा आपका simply 1 divided by 5, और v क्या है? 3, 4. So this is vector u. You can say that it is 3 divided by 5 or 4 divided by 5. So this is vector u, that is unit vector, and this vector u is in the direction of this vector v. So if it is vector v, then this will be vector u, that will, right? Now find the unit vector u, capital U, that is perpendicular to this small u vector. So this is small u. अब आपको क्या करना है? You have to find एक ऐसा वेक्टर जो कि परपेंडिकुलर हो दिस यू पे, राइट। और अगर ये स्मॉल यू पे परपेंडिकुलर है तो ऑब्वियस सी बात है ये जो होगा वी, ये वेक्टर वी जो है उस पर भी परपेंडिकुलर होगा। और ये u जो है ये भी क्या है, यूनिट वेक्टर है। सो दिस u इज ऑल्सो अ यूनिट वेक्टर एंड इट इज परपेंडिकुलर टू दिस वेक्टर u। और अगर इस स्मॉल u पे परपेंडिकुलर है तो इस v पे भी परपेंडिकुलर होगा। दैट मीन्स अगर हम लोग ये बिग u डॉट u निकाले, स्मॉल u, या ये कैपिटल U डॉट v निकाले, that should be equal to 0, right? So this v is given, right? So dotted with u is dotted with capital U, dotted with 3 4, and that should be equal to 0. So can you make any choice of u that if you take the dot product you will have at the end you will get the 0? So you can choose, right? So what you can choose is you can take u as -3 here, right? So that will be not -3, but you can take it as 4 here. और यहाँ पे आप कितना ले सकते हो, यहाँ पे आप सिंपली ले लो 3, right? And if you dotted with this vector v, then you will get this 0. करके देखो आप, 4 टाइम्स -4 टाइम्स 3 कितना होगा, -12, और 3 टाइम्स 4 कितना होगा, 12 होगा, +12, राइट? एंड एट द एंड यू आर गोइंग टू ऐड दोज, तो अल्टीमेटली आप इसका डॉट प्रोडक्ट लोगे तो you will get the 0. So that means this is a capital U, right? And is not exactly capital U, right? But because according to question this capital U is a unit vector, right? So let me write it down. This is also a unit vector, right? So let me call this U dash. So this is u dash, that is maybe this one, u dash. And now we have to find this u, right? So again same thing what we have done here. Now question is, give me a vector, give me a unit vector that is in the direction of this u dash, and that is the question, right? And how we can find this u? So that will be, so I want to find this unit vector that is in the direction of this u dash, right? And this u is a unit vector. That is why what I am going to do, I am going to divide this by the length of u dash, right? And what will be the length of u dash? So length of u dash, or the norm of u dash, will be root over of this 4 square plus 3 square. Now I am not going to write all these things, right? So again that will be 16 plus 9, that is 25, and 5. So length of u dash is 5. So आपका ये कितना हो जाएगा, unit vector u that is in the direction of u dash will be 1 divided by 5. So and u dash is -4, that will be -4 divided by 5 and 3 divided by 5, right? So now again we have one more question. How many possibilities of this capital U? So this U could be also in this direction, right? So this is our unit vector u, capital U, and this is again perpendicular to this small u and this v, right? So that could be in both directions, this capital U, right? And again this is our unit vector. So we can say that this vector u will be minus times of this one, because this is in opposite direction of what we have found, right? So that will be 4 by 5 and 3 by 5. So how many possibilities of u? So there are two possibilities of u, right? I hope it makes sense. Okay, so let's look at this question number 3. 3 पार्ट है इसमें. फर्स्ट पार्ट इज डिस्क्राइब एवरी वेक्टर w and this vector have two components. That means ये वेक्टर किसी 2 डायमेंशनल स्पेस से आया होगा. दैट इज परपेंडिकुलर टू v, और ये w जो है परपेंडिकुलर टू v है. सो डिस्क्राइब एवरी वेक्टर that is perpendicular to this v, right? So we need to describe every vector that is perpendicular to this v, right? So we can say that the dot product between them would be 0, right? If we take the dot product, that is v dot w, that would be equal to 0, right? And dot product हम लोग इजी वे में ले सकते हैं. So 2 minus 1 dotted with w1 w2, that is equal to 0, and from here what we can say that it will be 2w1 minus w2 is equal to 0, right? Now let's look at this one. So we can look at the geometry. v जो है वो 2 minus 1 है, right? So x1, and let's take as 2, and minus 1 would be somewhere here, minus 1 and 1. So vector v will be this one, right? Now एक बात आप ये देखो, ये this equation, so this is nothing but a straight line, right? So also you can directly tell me that what will be one vector that will be perpendicular to this v, right? So you can choose w1 is equals to 2 no 1, and w2 is equals to 2, right? अब आप इसका डॉट प्रोडक्ट लो इन दोनों का, इसका और इसका, राइट? सो दैट वुड बी 0, राइट? बट यहाँ पे क्या पूछा गया ना कि डिस्क्राइब एवरी वेक्टर, वो सारे वेक्टर जो इस वेक्टर v के परपेंडिकुलर है, राइट? सो one of the vector that is perpendicular to this v is this one, right? So if we have to draw this one, this, that is x is equals to 1 and y is equals to 2, so that will be somewhere here, right? So let's call this one, right? So अब आप एक चीज़ देखो कि इस लाइन पे, दैट ये इस लाइन पे जो भी वेक्टर होंगे, all those will be perpendicular to v, right? So on this line, whatever the vector is on this line, that is going to be the perpendicular to this vector v, right? So maybe we could have this vector also, that is the scaled version of this one, or maybe we could have this vector also. तो मैंने क्या बोला ना कि उस लाइन पे जो भी वेक्टर होंगे, इस लाइन पे जो भी वेक्टर होंगे, that could be even this one in this direction, right? So So in general, how we can write that this w vector that will be perpendicular to all w's that will be perpendicular to this vector v will be c times 1 2, right? And this c is any number, any real number, right? Now one question can be raised in your mind that we could have a vector that is shifted from this origin, right? We could have this vector also that is perpendicular to this v, राइट बट ये वेक्टर कुछ नहीं, ये वेक्टर सिंपली क्या है, आपने इसको पिक किया एंड यू कैन शिफ्ट वेक्टर राइट इन स्पेस, so you can simply pick this one and you can simply shift it to here, right? So overall point is that this line, all the vector that is on this line will be perpendicular to this vector v, right? Now let's look at this part b. All vector perpendicular to v, and this v has the three components, so it belongs to some three-dimensional space, lie on dash in three-dimensional. So इसमें क्या पूछ रहा है ना कि all vectors, वो सारे वेक्टर जो परपेंडिकुलर है दिस v वेक्टर के, वो सारे वेक्टर उस थ्री-डायमेंशनल स्पेस में कहाँ पे लाई करेंगे, एक पॉइंट एक लाइन पे लाई करेंगे या प्लेन पे लाई करेंगे या कंप्लीट थ्री-डायमेंशनल स्पेस में लाई करेंगे. ओके, सो all vector perpendicular to v lie on dash in three dimensions. So if you have, let's suppose you have this three-dimensional space, let me make it, or maybe we can directly see. So let's suppose there's this vector v, so this vector is from some three-dimensional space, right? So let me draw this one also, so that so this, let's suppose this one x, y, and this is z, and so this vector v will be here somewhere, right? And let's suppose this is vector v. Now all the vector, all the perpendicular, that is all the vectors that is perpendicular to this vector v will be where on the, so basically if we do not want to visualize it, how we can answer it, we can simply say that अगर मान लो कि कोई भी वेक्टर w है x, y, z, if this vector is perpendicular to this vector v, then their dot product will be 0, right? So we can take the dot product, that is v dot w, and we can say that 1 1 1 and this one is x, y, z is equal to w, right? So from here we can simply do the dot product, right? So dot product क्या होगा, simply x times 1 that is x, y times 1 that is y, and z times 1 that is z, and at the end you are going to end and you will get this. And what is this? This is nothing but a plane, right? Equation of a plane. And here we, in the first case, what we have got is the equation of line, right? So देखो ये रिलेशन तो सेटिस्फाई हो रहा है, डैट मीन्स कि जो भी वेक्टर परपेंडिकुलर होंगे इस v के, that all vector is going to lie on the plane, right? Let me I will show you the visual also. So all the vector, let me first write what will be the answer of this question. So all the vector perpendicular to V lies on a plane in a three-dimensional space. Okay, let me show it to you. So this is our coordinate system, right? And this one is our vector, right? So this one. Let me adjust little bit. So this is y. Right, I think now it is good. Right, and we got this x plus y plus z is equals to 0, right? This one, right? So basically what I want to see that this vector v and this plane, right? So these two should be let me show it to you. So this is the equation, this is the x plus y plus z plane, right? And you see that this red is the plane that is x plus y plus z. Take it the screenshot. Right, so this is vector v, right? This blue one is a vector v, right? And this is a plane that is x plus y plus z is equals to 0. And you see that you take any vector on this plane, so this vector belongs to this plane, any vector on this plane, either in direction or this direction, all these vectors are going to be the perpendicular to this blue one, right? So you can take any vector on this plane, this one, right? Okay, now let's come to this part third, part C, that the vector perpendicular to both. So we have given these two vectors, right, lie on, so the vectors perpendicular to both, so we have given two vectors. So इस केस में you will have so let's suppose ये सेम कोऑर्डिनेट सिस्टम रहेगा हमारा, राइट? अब इसमें क्या होगा ना कि ये आपका जो एक और वेक्टर आएगा, दैट वुड बी समथिंग वेक्टर, यू कैन से दिस v, this one is v, and let's suppose this is maybe x or y, or let's call it anything w. so ये जो w वेक्टर होगा समवेयर यहाँ पे होगा 1 2 3 मान लो, राइट? तो अब अगर कोई वेक्टर, कोई एक वेक्टर, अगर जैसे कि मान लो कि कोई भी वेक्टर, मान लो कि आप u वेक्टर है कोई, दैट इज x y z, ये परपेंडिकुलर है बोथ टू बोथ v के भी और w के भी, दैट मीन्स कि इट विल सेटिस्फाई दिस कंडीशन। अगर डॉट प्रोडक्ट उनका क्या होगा, 0 होगा, राइट? सो u डॉट w इज इक्वल्स टू 0 एंड v डॉट u इज इक्वल्स टू 0, ये दोनों 0 होगा, राइट? एंड व्हाट यू विल डू, यू विल फाइंड द डॉट प्रोडक्ट। सो v तो आपका ये है, ठीक है, और यू आपका ये है। तो फर्स्ट इक्वेशन आप डॉट प्रोडक्ट फाइंड करोगे, क्या होगा, एक्स प्लस वाई प्लस जेड इज इक्वल टू जीरो। एंड दूसरा इक्वेशन क्या हो जाएगा, एक्स प्लस 2y प्लस 3z इज इक्वल टू जीरो, राइट। Now what you have to find is that vector perpendicular to both those vector। हमें उन सारे वेक्टर्स को फाइंड करना है ना जो इस v एंड w दोनों पे परपेंडिकुलर हो, राइट। सो दिस describes a plane, also this describes a plane in 3 dimensional space। so जहाँ पे इन दोनों प्लेन का इंटरसेक्शन होगा, so the intersection of these plane would be a line, right, and that line will is going to be the common for both of these plane, right। जहाँ पे इंटरसेक्शन होगा वो लाइन, दो प्लेन जब इंटरसेक्ट करते हैं तो एक लाइन पे इंटरसेक्ट करते हैं, राइट। सो और वो लाइन जो होगा दोनों के लिए कॉमन होगा, दोनों प्लेन के लिए, फॉर दिस प्लेन ऑल्सो एंड फॉर दिस प्लेन ऑल्सो, राइट। एंड अगर तो दोनों की इक्वेशन को सेटिस्फाई करेगा वो पर्टिकुलर लाइन, राइट। एंड इफ ये प्लेन अगर परपेंडिकुलर है v के, राइट, और ये प्लेन परपेंडिकुलर है दिस w के, राइट। सो दैट मीन्स w वेक्टर के परपेंडिकुलर है ये प्लेन, और जहाँ पे इन दोनों का इंटरसेक्शन होगा वो कॉमन होगा। दैट मीन्स कि वो जो लाइन होगा दैट विल बी परपेंडिकुलर टू बोथ v एंड w। लेट मी शो इट टू यू। सो एक तो हमारा ये v ऑलरेडी है, दैट इज़ 1 1 1 दिस वन, राइट। और एक प्लेन तो ये ऑलरेडी है हमारा दिस वन, राइट, दिस वन, और ये वेक्टर v है। नाउ एक और वेक्टर आया दिस वन, राइट, 1 2 3। एंड अब क्या बोल रहा है ना कि दोनों वेक्टर के परपेंडिकुलर सारे वेक्टर्स को फाइंड करना है, ठीक। तो दोनों से डॉट प्रोडक्ट निकाले तो दो इक्वेशन आया प्लेन का, राइट। तो ये प्लेन एंड ये दोनों प्लेन जहाँ पे इंटरसेक्ट करेंगे एक लाइन फॉर्म करेंगे। तो आप लेट मी शो इट टू यू। So you see that this red one and this blue one, ये रेड वन को देखो ये दोनों जहाँ पे कट कर रहे हैं, हाँ, लेट मी टेक स्क्रीन शॉट एंड शो इट टू यू। हियर इट इज, कॉपी डिलीट, okay, I think let me make some space here। राइट, एंड वी हैव दिस वन। तो ये देखो यहाँ पे इंटरसेक्ट कर रहा है दोनों प्लेन, ये रेड और राइट। एंड जितने भी वेक्टर्स आप लो इस लाइन पे, ऑन दिस लाइन, so all the vectors that is on this line will be perpendicular to both। कोई भी वेक्टर ले लो आप इस लाइन पे, right। So that will be perpendicular to both on this w and this v, right। So इतना एक्सप्लेन करने का इस क्वेश्चन को क्या ज़रूरत है, थोड़ा इसमें है, ये आपको काम आएगा आगे. This visualization will be useful in further lecture, so that is why I explained this much. Okay, now let's move. Okay, so तो इसका आंसर क्या हो जाएगा, द वेक्टर्स perpendicular to both these vectors lie on line. So let's look at this question number 4. So ये आप लोग ट्राई करिएगा, इसमें सिंपल है. So I do not have to read, you can go through that. Question number 5, same, you can consider it as your homework problem. Question number 6, it's a good question, it's a true false, but it's a good question, you can try. So if u is perpendicular to v and w, then v is parallel to w. So you have to read it. आप इसको पढ़ो and you can समझो और try to answer. And ये 6 का b you try, and this c also you can try, but let me just give you an overview. If u easy one है, but u and v are perpendicular unit vector. So let's suppose this u and v is perpendicular unit vector, right? Then what it is saying that आप इनका डिफरेंस लो, that means कि you will get another vector and उसका length लो, so that will be root under 2, that you have to check, right? So you can think this one, right? So how you can proceed. Suppose आपको बेसिकली फाइंड क्या करना है, लेंथ ऑफ u माइनस वी, राइट? सो u माइनस वी जो होगा वो स्टिल एक वेक्टर होगा, एंड यू हैव गिवन द इंफॉर्मेशन अबाउट u एंड v, राइट? बोला गया है कि u जो है, v जो है, बोथ आर यूनिट वेक्टर एंड परपेंडिकुलर टू ईच अदर. इफ u एंड v आर परपेंडिकुलर यूनिट वेक्टर, right? So now you have to find this length first of all. How you will find the length? What I have told you that how you are going to find the length. Just take the dot product. It will give you the. Just take the dot product with itself. If I ask you that, what will be the length of this vector w? What you will do? Simply take the dot product with itself. It will give you the length square, right? And take the root over of that one, that will give you the length of vector w, right? अगर आपको ये u minus v का length find करना है, so u minus v is nothing but a combination of linear combination of u and v, and this u minus v will again a vector, simple, you can take it as as a w vector, or let it be u minus v, right? So if I ask you that what will be the vector, what will be the length of this vector u minus v, what you will do? You will simply take the dot product with itself, right? So, and what you can write this one as u square, right? And minus of u v, and these two are perpendicular, we have given, right? So that is going to be again 0, and minus uv, this will be again 0, and plus v square, right? And these two are unit vector, so this will be 1 plus 1, right? And this is nothing but the length square, right? और फाइंड क्या करना है, लेंथ फाइंड करना है, तो क्या हो जाएगा, रूट ओवर ऑफ इसका 2, right? So try this one also, you will get it. Okay, now let's look at this question number 7. This one is also easy, just you have to see what it is asking. v dot w is negative. So if you are taking the dot product between two vector, it is negative. What does this say about angle between v and w? अगर डॉट प्रोडक्ट आपका निगेटिव आ रहा है, इज लेस देन जीरो, सो जीरो कब आता है? जीरो अगर मान लो ये आपका डब्लू है और ये आपका वी है, दैट इज जब परपेंडिकुलर होगा वी डब्लू के, तो क्या होगा इस केस में? वी डॉट डब्लू इज इक्वल टू जीरो होगा। अगर वी जो है, दो वेक्टर जो है ऐसा एंगल बना रहा है जो कि ग्रेटर देन लेस देन 90 है, ठीक, ये एंगल, राइट। अगर ये आपका डब्लू है, ये वी है, तो इन दिस केस जो होगा वी डॉट डब्लू ग्रेटर देन जीरो होगा, राइट। Also you can see this dot product as a projection, so what you find is this length, this one, right? So we will talk about this on this more when we will go through the chapter that is projection, right? और एक केस क्या होगा जब आपका इन दोनों के बीच जो एंगल हो ग्रेटर देन 90 डिग्री हो, तो दिस इज द एंगल इज ग्रेटर देन 90 डिग्री। तो इस टाइम जो ये प्रोजेक्शन होगा वो v के पीछे साइड में बनेगा, राइट, बैक ऑफ द v, सो दैट यू कैन से दैट दिस विल बी निगेटिव। सो इन दिस केस v डॉट w इज लेस देन जीरो, राइट। नाउ नेक्स्ट क्या बोल रहा है ना कि ड्रॉ ए 3 डायमेंशनल वेक्टर u एंड सो वेयर टू फाइंड w's with v dot w is less than 0. So let's suppose you have this vector that is in from some 3-dimensional space, vector v. अब क्या बोल रहा है ना कि आप सारे w's को फाइंड करो और that should be in 3-dimensional space and ये डॉट प्रोडक्ट जो होना चाहिए लेस देन जीरो होना चाहिए। अब देखो अगर आपका ये w है यहाँ पे, अगर इसका एग्जैक्टली परपेंडिकुलर है तो ये W इस केस में क्या होगा? डॉट प्रोडक्ट क्या होगा इस केस में? व्हाट विल बी द डॉट प्रोडक्ट नाउ इन दिस केस? V डॉट W जीरो होगा। तो और ये इधर जितने भी इधर W बनेंगे जहाँ पे एंगल ग्रेटर देन 90 डिग्री होगा, ये जितने सारे W होंगे, नाउ अब इनका आप डॉट प्रोडक्ट लोगे V के साथ, so that will be negative. So what will be the answer of this question? That so where to find all w's? तो ये जितने सारे w हैं जो इस कंडीशन को सेटिस्फाई करेंगे वो आपका जो है हाफ ऑफ द 3-डायमेंशनल स्पेस को ऑक्यूपाई करेंगे, राइट। हाफ ऑफ द 3-डायमेंशनल स्पेस को ऑक्यूपाई कर लेगा, क्योंकि इस डायरेक्शन में तो अगर इस w ये w दिस w विल गिव यू द पॉजिटिव, राइट। इफ यू टेक द डॉट प्रोडक्ट दैट विल बी पॉजिटिव। सो ऑल दिस w, राइट, सो वेयर टू फाइंड ऑल दिस w? सो इन 3-dimensional space all these w will occupy this half of the space of 3-dimensional space. Okay, now let's look at few more questions. Okay sir, this question you can try. सिंपल है, हम लोगों ने डिस्कस किया है कि हाउ टू फाइंड द लेंथ ऑफ अ वेक्टर in n-dimensional space, right? So how long means it is asking the length is the vector v in 9 dimension. Find the unit vector u in the same direction as v and unit vector w that is perpendicular to v, right? So you can take it as a homework problem. Okay, now let me just close this lecture by so few points that you take the dot product v dot w or w dot v, that is going to be the same, right? And u dot v plus w, right? So you can distribute this u to v and w, right? And that will be equal. So that will be u dot v plus u dot w, right? And this third one is that associativity, right? So let's suppose that this c is some constant and this v is some vector, and this w, right? So what you can do, you can find, you can either multiply this constant to this vector v, that means आप स्केल कर सकते हो दिस, पहले आप स्केल कर दो, देन यू टेक दिस डॉट प्रोडक्ट, और क्या करो आप पहले आप डॉट प्रोडक्ट ले लो, राइट, एंड देन यू स्केल इट, दोनों बातें बराबर होंगी, ठीक है? तो ये कुछ थे ऑब्वियस पॉइंट थे, बिकॉज यू कैन डायरेक्टली चेक इट, आप डायरेक्ट इसको चेक कर सकते हो अगर कन्फ्यूजन है तो. Okay, I think these are the few main points that I wanted to bring through this dot product and this length and this unit vector. Okay, so इसमें जो homework problem होगा, I hope you will try, right? So सारी easy है, so I do not have, I think I will not have to explain. So you can try and comment if you have difficulties in any of the problems. Then I will come up with the solution. Otherwise, we will know. I am not going to go through the homework problem of this particular chapter because those are obvious and easy to solve. If you have problem, then you can comment the question number. I will come up with next video. Okay. Now we are done with this chapter, the subtopic of this topic, right? So we are done with this length and dot products. In next video we will be looking at this matrices, right? So we will start with this matrices, and this is very important, right? Lot of point I will be explaining. So you see that